June 2002, a suburb just outside Detroit, Michigan. A man stands in his backyard staring up at an ash tree he planted himself. The crown is thinning, the bark is splitting, and under that bark, something is moving. He doesn't know it yet. But that tree is already dead. So is the one next door. So are the ones down the street, and the ones in the park, and the ones lining the highway for 100 miles in every direction. A green beetle, no longer than a grain of rice, has just been found in North America for the first time. And in the next 20 years, it will kill more trees than any insect in the history of this continent. We will spend $12.5 billion trying to stop it. We will fail, and then something will step in that no one was watching. Something with feathers. Something that worked for free. I'm Edmund Tail, and this is the full story of how a single beetle nearly erased an entire kind of tree from America, how the most expensive insect war ever fought went almost nowhere, and what the data now reveals about the small, ordinary bird that did the job we couldn't while we weren't even looking. Now, before I go further, I want to correct something you're probably picturing. When you hear the word pest, you imagine something you can see, something you can spray. A swarm, a cloud, a thing that lands on your skin. The emerald ash borer is none of that. For almost its entire life, you will never see it. It lives behind the bark, in the dark, in the soft living tissue of the tree, the exact layer the tree uses to move water and food. By the time you notice anything is wrong, the damage is already years old. The fight is already lost. That's what made this beetle so dangerous. Not its size, not its strength, its invisibility, and the hole it left behind, the gap it tore open in the forests of this country, was so large that we threw money at it for 2 decades and barely slowed it down. But there's an uncomfortable truth buried in this story. And it's this: the thing that actually held the line was never in our budget. We didn't fund it, we didn't plan it, we almost didn't notice it. Let me show you how all of it happened. Start with the beetle itself. The emerald ash borer comes from northeastern Asia, China, Korea, parts of Russia, and Japan. Over there, it's a minor nuisance. The local ash trees evolved alongside it for thousands of years, so they learned to defend themselves. The local predators learned to eat it. The whole system kept it in check. In its homeland, this beetle is nobody. It almost certainly arrived in America the way so many invasive species do. Inside wood, probably wooden packing material, shipping pallets, crates, the cheap timber used to brace heavy cargo. It rode across the ocean in a container, slipped through a port, and stepped off into a continent with no idea what it was. And here is the part that matters. The North American ash tree had never met this beetle before. Not once. Not in 10,000 years. So it had no defenses, none. There are several species of ash across the United States and Canada. Green ash, white ash, black ash, blue ash. Together they numbered in the billions. They lined city streets because they grew fast and gave deep shade. They filled the swamps and the river bottoms. In some northern forests, they made up a huge share of every tree you could see. To the emerald ash borer, all of that was an open buffet. Endless food. No predators, no resistance. Here is how it kills. An adult female beetle lands on the bark of an ash tree. She lays her eggs in the cracks and crevices, sometimes dozens of them. When the eggs hatch, the tiny larvae chew straight down through the bark into the layer underneath. That layer is called the cambium. It's the living tissue, the part of the tree that carries water up from the roots and sugar down from the leaves. The larvae eat that layer, and as they eat, they tunnel, they carve long, winding, shaped galleries through the wood, back and forth, packing them with sawdust and waste. One larva is nothing, but there aren't ever just a few. When the galleries multiply, they do something brutal. They wrap around the trunk, they cut the tree's plumbing, water can't reach the crown, food can't reach the roots. The tree is strangled from the inside out, slowly, over 2 to 4 years. You see it from the top down. The upper branches die first because they're farthest from the roots. The crown thins, then the tree panics, and it sprouts strange new shoots straight out of the trunk, low down, a desperate attempt to grow leaves anywhere it still can. The bark splits, and if you peel a piece back, you find them. Those winding tunnels, that packed sawdust, the proof. By then it's over. The kill rate is the part that stops you cold. When the emerald ash borer moves into a stand of untreated ash trees, it doesn't kill some of them. It kills almost all of them. The numbers from the field are staggering. In many infested areas, more than 99% of the ash trees died. Not 90, not 95, more than 99. That's not a pest. That's an extinction level event for an entire kind of tree. And once it was loose, it moved. Beetles fly, but not far on their own, maybe a few miles a year. That alone would have given us time. But the beetle had a partner it didn't even know it had. Us. We moved it in firewood. A family loads cut logs into the back of a truck for a camping trip. Inside that firewood, hidden under the bark, are larvae. The truck drives 200 miles to a campground in a brand new county. The beetles emerge in spring, and a fresh infestation begins 200 miles ahead of the front line in a place the beetle could never have reached by flying. That's how a slow insect crossed a continent fast. From that one spot near Detroit, it spread to Ohio, to Indiana, to Pennsylvania, Maryland, Virginia, west into Illinois and Iowa and Missouri, north into Canada, south toward Louisiana and Texas. Today, it has been found in more than 35 states. And we knew very early that this was going to cost us. We just had no idea how much, so we fought back. And the war we waged was enormous. Here's the first thing we tried. Quarantine. The logic was sound. If the beetle spreads in firewood, then stop the firewood. Officials drew lines on the map around infested counties and made it illegal to carry ash wood or firewood across them. Signs went up at state borders and campground entrances. Don't move firewood. Buy it where you burn it. It became one of the largest public awareness campaigns about an insect this country had ever run. It helped. It slowed things down, but it could not stop it, because all it takes is one person, one truck, one bundle of logs that crosses a line it shouldn't. And there were millions of trucks, so we escalated. The second thing we tried was the chainsaw. Pure removal. In the early years, the strategy in some places was to cut down every ash tree within a certain radius of a new infestation, healthy or not, and grind it to chips. The thinking was, if you take away the food, the beetle has nothing to breed in, and you stop it cold before it gets established. Picture that. Crews moving through neighborhoods, marking healthy shade trees with paint, then dropping them one after another. Trees that had stood for 50, 60, 70 years. Gone in an afternoon, people came out of their houses and begged them to stop. It didn't work either. The beetle was already further ahead than anyone realized. By the time you found one infested tree, there were already dozens more nobody had spotted, the damage still hidden behind the bark. We were cutting down trees behind the beetle while it was already breeding in front of us. So we escalated again. The third thing we tried was chemistry. Insecticide. And this is where the real money went. For a high-value tree, a street tree, a beloved tree in someone's yard, a landmark on a campus, you could save it. There are insecticides that get injected directly into the trunk or applied to the soil, and the tree pulls the chemical up into its own tissue. When the larvae chew into that tissue, they're poisoned. It works. It genuinely works. But there's a catch, and it's a big one. You have to do it forever, or close to it. The treatment lasts a year or two, sometimes 3. Then you do it again, and again, for as long as the beetle is in the area, which is essentially forever, and it costs money every single time. Tens, sometimes hundreds of dollars per tree, per treatment. Now do the math on a city. A single town might have tens of thousands of ash trees lining its streets. You cannot inject all of them forever. It's impossible. So cities were forced into a horrible kind of triage. Save a few, treat the special ones, the big ones, the historic ones. and let the rest die, then pay to cut them down and haul them away before they fell on a car, a roof, a person. Because that's the other cost nobody thinks about. A dead tree is dangerous. A dead ash tree is especially dangerous because it gets brittle fast and drops heavy limbs without warning. So every dead tree along a street or a sidewalk became a liability that someone had to pay to remove. And that bill kept climbing in ways that should make all of us stop and think. If this kind of story pulls at something in you the way nature fights back, the way ecosystems find their own answers when we're not paying attention, I want to point you towards something I've put together outside of this channel. It's a digital book called Rewild, and it goes deeper into exactly this territory. What happens when we step back, when we protect instead of control, and when the wild reclaims what we nearly destroyed. There's also Wild Return and Rewild Deeper for those who want to keep going. You can find them through the description. These aren't textbooks. They're the kind of reading that changes how you look out a window. But back to the story, because the most astonishing part is still ahead. Add it all up. The quarantines, the surveys, the trapping, the removals, the replanting, the insecticide treatments, year after year after year. Researchers estimated that just treating, removing, and replacing the ash trees on developed land in American communities would cost on the order of $12.5 billion. $12.5 billion to fight an insect the size of a grain of rice. And that figure doesn't even capture the trees in the wild forests, where no one was treating anything, where the beetle simply ran free. So step back and look at what we'd built. The most expensive insect control effort in the country's history, quarantine lines across dozens of states, chemical treatment on a massive scale, an army of arborists and inspectors and scientists, and the beetle kept spreading anyway. Now here's the turn. Because while all of that was happening, while we were spending billions and losing, something else was happening in those same forests, quietly, for free, and almost nobody was looking up to see it. The forest had its own answer. It had feathers. Think about what the emerald ash borer actually is. Once you strip away the fear, it is a fat, protein-rich larva sitting in a tunnel just under the bark of a tree all winter long, not moving. To the tree, that's a death sentence. But to a bird that makes its living digging insects out of bark, that is a meal. A buffet, packed under a thin wooden lid, waiting. And North America has exactly the kind of birds built for that job. Woodpeckers, the downy woodpecker, the hairy woodpecker, the red-bellied woodpecker, the white-breasted nuthatch, which forages the same way. These are birds that spend their entire lives clinging to tree trunks, tapping, listening, chiseling, pulling grubs out from behind the bark. It is the one thing they are perfectly designed to do. A woodpecker's skull is built to absorb the shock of hammering wood. Its tongue is absurdly long, longer than its own head, and it wraps around the inside of the skull when it's not in use. The tip of that tongue is barbed and sticky, a built-in harpoon for spearing larvae out of tunnels. Its tail is stiff, to brace against the trunk. Its toes grip bark like crampons. This bird was built over millions of years for exactly one task. Find the grub in the wood, get it out, eat it. And then America handed it billions of new grubs. Here is the part that stunned the researchers. When scientists started looking closely at infested forests, they found that the woodpeckers weren't just nibbling at the edges, they were feasting. And they were doing it at a scale that genuinely mattered to the beetle's survival. In some infested stands, woodpeckers and other bark-foraging birds were killing a huge share of the emerald ash borer larvae. The studies found rates that ran from around a third of the larvae in some places to as high as 85% in others. In certain trees, the birds were taking the majority of the next generation of beetles before they ever grew wings. Let that land. We spent $12.5 billion and couldn't stop this thing. And a downy woodpecker working alone on a single tree in the cold was removing up to 85% of the larvae inside it for nothing. For the price of a meal it wanted anyway. But it gets better, because the woodpeckers didn't just eat the beetles. They responded to them. This is the detail that changes everything. Animals go where the food is. It's the oldest rule in nature. And when a new, abundant food source appears, the animals that can exploit it move in, and their numbers grow. That's exactly what the data showed. Researchers used one of the most powerful tools in modern ecology, the records gathered by ordinary birdwatchers across the continent, the kind of data collected through programs run by places like the Cornell Lab of Ornithology, millions of observations, years of records. Birds counted in the same places season after season by thousands of people. And when scientists compared bird numbers in areas the emerald ash borer had invaded against areas it hadn't reached yet, they saw a clear signal. In the invaded zones, the bark-foraging birds increased. Woodpeckers, newthatches, the exact birds that eat wood-boring larvae. Their populations rose where the beetle had arrived, and the increase lined up with the timing of the infestation. The forest was handing these birds an enormous new supply of food, and the birds answered the way nature always answers. They showed up, they ate, and they raised more of themselves. Nobody organized this. Nobody funded it. There was no agency, no budget line, no press conference. The birds simply did what birds do. They found the grubs and they got to work. And here's the mini twist that opens the next door. The woodpeckers couldn't save the ash tree. Let's be honest about that. By the time enough beetles were in a tree to attract the birds, that tree was usually already doomed. The woodpeckers weren't curing infected trees. They were doing something different, something slower, and in the long run, maybe more important. They were changing the math of the whole invasion. Let me explain what that actually means, because this is where the hope lives, and it's not the kind of hope you're expecting. When an invasive species first arrives, it explodes. No predators, no resistance, unlimited food. The population shoots straight up, almost vertical. That's the killing phase. That's when the forests collapse, and the cities lose their canopy, and the bills come due. But no explosion lasts forever. As the easy food gets used up, and as the predators catch up, the curve starts to bend. The woodpeckers are part of what bends it. Every larva a woodpecker eats is a beetle that never flies, never mates, never lays eggs in the next tree. Multiply that by millions of birds across millions of trees, season after season, and you start to apply a real brake on the population. You don't stop the invasion, but you slow its growth. You shave the peak off the explosion. You buy time. And time is the one thing that matters most, because time is what lets the rest of the system catch up. While the woodpeckers were eating, other things were happening too. Scientists were releasing tiny parasitic wasps from the beetle's homeland in Asia, wasps that attack only the emerald ash borer and lay their eggs inside its larvae and eggs. These wasps were chosen carefully and tested for years to make sure they wouldn't harm anything else. They're now established across many states, slowly building their own populations, doing their own version of what the woodpeckers do, attacking the beetle from yet another angle, and the trees themselves were doing something quiet and astonishing. Out in the forests, after the beetle swept through and killed more than 99% of the ash, scientists kept finding survivors. A small number of green and white ash trees that stood alive in the middle of fields of the dead. They called them lingering ash. Trees that, for some reason written in their genes, were a little more resistant, a little better at fighting back. Those survivors are the future because their seeds carry whatever made them tough. And researchers are now collecting those seeds, breeding those trees, working to build a new generation of American ash that can stand up to the beetle on its own. Do you see the shape forming? The woodpeckers don't win the war by themselves. Nothing does. But they're a crucial part of a larger thing that is finally, slowly beginning to work. A predator catches up, a parasite catches up, the trees evolve. The beetle, which once had everything its own way, starts to meet resistance from every direction at once. That is how an invasion ends. Not with a single hero. With a system that closes back in around the invader, piece by piece, until the explosion settles into something the forest can live with. And here's the uncomfortable part, the part I promised you at the start. We spent $12.5 billion. And the single most effective natural check on this beetle across the widest area may have been a bird we never paid a cent, never trained, never deployed, a bird that was already there, a bird whose only requirement was that we leave the forest standing long enough for it to do its job. Now think back to the chainsaws, back to those early years, when one strategy was to cut down every ash tree for a radius around each infestation. Healthy trees, whole stands. Ground to chips. Here's the catastrophic irony hidden in that. Every ash tree we cut down was a tree the woodpeckers could no longer hunt in. Every stand we cleared was a hunting ground we erased. In our panic to starve the beetle, there were places where we may have starved its predators right alongside it. We were so focused on fighting the invader directly that we sometimes tore down the very system that was already fighting it for free. That's the pattern. That's the thing this whole story is really about. We are very good at the big, expensive, dramatic response. The quarantine, the chemical, the chainsaw, the billion-dollar program. We are very bad at the quiet, patient, humble move. The one where you trust the system, where you protect the predator, leave the survivor standing, and give the forest the time it needs to heal itself. Let me be clear about what I'm not saying. I'm not saying the money was all wasted. The treatments saved beautiful, irreplaceable trees in our cities. The quarantines slowed the spread and bought time, and time mattered. The science was real and necessary, especially the work on the wasps and the resistant trees. But the headline number, the 12.5 billion, tells you where our instincts pulled us. Toward control, toward fighting, toward doing something big and visible we could put our name on. Meanwhile, the downy woodpecker, the size of your hand, sat on a dying ash tree in January, cocked its head, listened for the larva chewing in the dark beneath the bark, and drove its bill into the wood. Again, and again, and again, pulling out beetle after beetle, asking for nothing, reported by no one, funded by no budget on Earth, and doing it across an entire continent all at once. So step back and look at the whole shape of it. A beetle the size of a grain of rice arrives near Detroit, around 2002. It has no predators here, no resistance, billions of defenseless trees to eat. It tunnels under the bark, strangles the tree from the inside, and kills more than 99% of the ash in the areas it reaches. We move it across the country in our own firewood, jumping it hundreds of miles at a time until it infests more than 35 states. We respond with everything we have: quarantine lines, tree removal, insecticide injections repeated year after year, a bill that climbs to roughly $12.5 billion. And still, the beetle spreads. And then, the count that should be on every front page. Woodpeckers and other bark-feeding birds increasing in number wherever the beetle arrives, removing up to 85% of the larvae from infested trees. A predator that was already here, a predator that scaled itself up to meet the threat. A predator that never sent us an invoice. We didn't engineer that. We didn't deploy it. We didn't even notice it at first. And that's the lesson that keeps repeating in every one of these stories. We didn't save the forest with our chemicals. We didn't outspend the beetle. The most powerful thing we did was, in the places where we managed it, simply leave the trees standing long enough for the animal that already knew how to fight back to do exactly that. We keep trying to be the hero, and the real hero keeps turning out to be the thing that was there the whole time, the thing we almost cut down by mistake, the thing that worked for free while we wrote checks for billions. So I'll leave you with the question I can't stop turning over. If the cheapest, most effective soldier in the most expensive insect war in our history was a bird that asked for nothing and we barely thought to protect, what does that say about every other fight we think we're winning with money alone? Is that a wonder, or is it a warning? If you found this as remarkable as I do, let me know in the comments. I want to hear it. Do you think we should be spending billions trying to fight invasions like this head on? Or should more of that money go into protecting the predators and the habitats that fight them for free? Tell me where you land. If this changed how you think about pests, or about woodpeckers, or about how nature actually heals, share it with someone who'd appreciate it. The person who plants trees, the person who feeds the birds, the person who still thinks the answer is always a spray can. And subscribe. There are more of these comeback stories than you'd believe, hidden in the data, waiting under the bark, and I've got plenty more to tell you. I'm Edmund Hale. Thanks for watching.